Good morning, MAB Snakes, Mental Math. Get your paper and pencils, bring your math brains to the table, and we're ready to go. Here in a beautiful springtime day out on the porch by my office in Leesburg, and I'm here to stimulate your brains with mental math. Last week we did snakes, we did short division problems, and I showed you how to do that. Today I'm going to show you how to do long division with the thought that when you guys come back to the classroom, whenever we can reopen, we'll be showing you, and you get to use the racks and tubes to really understand deeply how division works. I'm going to show it to you with abstraction here, just working on it with pencil and paper. So here we go. The store has 864 bottles of soda on the shelves, and each shelf holds an equal amount. There are 4 shelves. How many bottles of soda are on each shelf? All right, so how many on each? That tells you it's a division problem. So we've got a dividend, that's the big number, 564 bottles of soda. Hold on, let me make myself more room here. 564, and we've got 4 shelves, so we're going to distributive division. We're going to distribute those 564 bottles of soda. We're going to put them on 4 shelves. Well, that means the divisor in this dividend is going to be divided by 4 shelves. Let me show you a special way that we record long division. It's an algorithm. You see that? That's how we put it on there. And that's different than the horizontal division equation we did last week. But this is long division. So let's see how it works. So we always start with the highest place value in division. So we want to give 500 bottles of soda to 4 shelves, distributed among 4 shelves. So each shelf would get 100, wouldn't it? And we'd use, of those 500s, we'd use 4, because each shelf would get 100 and 4 shelves, so it'd be 400. So that means we've distributed 400 of our 564 cans of soda. So we gotta distribute that. It's gone. We gotta take it away. It's a subtraction. So I've given away 4 of the 500, so I have 100 left, don't I? And this is how you record long division. Now, I need to bring down that 6 tens, and I like to draw that little arrow there so I can keep track of what I'm doing in the place value. So I'll bring down that 6 tens. So now I've got 106 tens, okay, all right, or 16 tens to distribute to the 4 shelves. So I got to take 16 tens and put them on the 4 shelves. Well, again, this is where your mental math facts comes in. Remember, multiplication is the reverse of division, so get out your finger chart if you don't know your math facts, because right now you got to know how, if I give 16 to 4 guys, each shelf is going to get 40 cans of soda, okay? Because 4 times 4 is 16. So I'm distributing those 16 tens, those 160 cans of soda, right, to the 4 shelves, and each shelf is going to get 40. So 4 times 4, I've given away all 16 tens of the soda cans, and I've got 0 tens left. So I've given away 500 to the 4 shelves, distributed. I've given away 66 tens to the shelves, all right? And each guy got 16, sorry. And now I'm gonna give away the 4 units. I'm gonna distribute the 4 units, and that comes all the way down here to where I'm working, 4 units. So if I'm going to give 4 units, distribute 4 units to 4 shelves, each shelf is going to get 1 can of soda. And I've given away all 4 of those units. So at the end, I've got 0. So when I distributed 564 cans of soda to the 4 shelves, each shelf got 141 cans. That's long division. It's a little bit complicated to see just in the abstraction. That's why racks and tubes is so cool. And of course, you guys have done this with Stamp Game as well, so you can see how distributing the dividend to the number of in the divisor works out. I'll do another one for you. And again, you can freeze the video, go back and look at this carefully. Make sure you track and understand how Mr. T did that long division problem. So there were 540 golf balls. They were put in buckets that had to have the same number of balls in each bucket. There were 4 buckets. So how many of the 540 balls were put in each bucket? The typical division problem. And division is very practical, you know, because these are the kind of things you'd have to do. You know, if you were working at a golf course and you had to take a whole bag full of balls and put them in equal buckets so they could go to the driving range and the golfers could hit them, then you'd have to be able to do this division, wouldn't you? Okay, so we have 540, I'm gonna write it here, 540 golf balls, and we're gonna distribute them, divide them into 4 buckets. Distribute, put those golf balls in the bucket, and each one of them's got to be fair, equal. So again, I have 500s to distribute to 4 buckets. So each bucket's going to get 1, aren't they? And in the process of doing that, I will have used up, because each bucket gets 1, and I've got 4 buckets, I will have used up 400 of the balls. So I'll still have, subtract that, take it away, it's been used, distributed. I have 100 left. Actually, I have 140 left, but just right here in the 100 place, I've got 100. So I bring down my 4 10s. And remember, so that's actually 14 10s or 140. But all we're working on right now is the 100 place value and distributing the 10s place value. So I now have 140 golf balls left, or 14 10s. And I want to distribute those 14 10s to 4 buckets. So how many 10s is each bucket going to get? Well, each bucket's going to get 4 times 4 would be 16, so I don't have 16. 4 times 3 would be 12. So 3 is 12. If I distribute 14 10s of golf balls to 4 buckets, each one's going to get 3 10s, 30 balls. By the way, this answer that I write on top of the algorithm up here, that's called the quotient in division. So here we go. I've done 14 distributed to 4 buckets. Each one got 14 10s to each bucket. Each one got 3 10s. 3 times 4 is 12, so I've used 12 10s. Got to take that away, they're gone. All right. So now I've got 2 10s left, and I have to bring all the way down that unit. Unit place value holder, 0 units. But I still got to bring it down, because I've got 2 10s, and 2 10s equals 20. And I got to distribute 20 now to 4 buckets. Again, mental math, we know that 4 taken 5 times is 20, so each bucket is going to get 5 more balls, right? 5 more balls. 5 times 4, I will use 20 of the balls, and I have 0 left, and I've got my quotient. If I want to distribute 540 golf balls to 4 buckets, each one is going to get 135 golf balls. Story problem. Got to have a word in the answer. This is long division. Think about it. Review the video. And again, we'll work hard on this with racks and tubes when you guys come back to school. But for those of you who are moving on and graduating and going on to a new school, this is long division that you'll need to know. And Mr. T is showing you how to do it with big dividends divided by divisors. Here we go. There are 3,204 patches in a quilt. A quilt is a blanket sewed together with individual patches. A quilt, 3,204. If the man making the quilt can do 9 patches in an hour, how many hours will it take him to make the quilt? See, it's a very practical math question, isn't it? Want to know how long it's going to take a worker to make a quilt? Okay, that's going to have 3,204 patches. That's going to be a heck of a big quilt, isn't it? So let's see. We need to take 3,204 of these little patches, and we need to distribute them, okay? And he's going to do 9 patches an hour, all right? 9 patches an hour. So in each hour, how many patches is he going to be able to do? We've got 9 of them, so we've got to distribute those patches to the 9 hours. Distributive long division. This is a tricky one. So, can I distribute 3 patches to 9 guys? 6 guys would get none. So that's not fair, and division always has to be fair. We have to give out the right amount. So we can't do the 3 units in thousands distribute to 9. So I go to the next place value. So now I have 32 hundredths. That's the 100 place value. So can 32 hundredths be distributed to 9 guys? And if I did that, to 9 hours, and if I did that, how many would he be able to do in each hour? Well, let's see. 9 times what gives me a number close to 32? Well, 9 times 4 is 36. So I don't have 36, I only have 32. 9 times 3 is 27. Well, let's try 3 as a quotient. 3. So maybe each one of those hours, in each one of those hours, the worker can do 300 patches. Well, let's see. 3 times 9 is 27. Okay, so he can, of the 32 that I've given him to the 9, I've distributed to the 9 hours. In each hour, he's going to be able to do 3. Then over 9 hours, he will have completed 27 of the patches. So what do I have left? Well, it's a dynamic subtraction. I got to figure out what I've used. All right, so I can't take 7 hundredths from 2 hundredths. I can make this a 2 and exchange it for 12 hundredths. Now I've got 5 hundredths. And 2 units in thousands, nothing goes there. So I figured out that if I take 3,200 or 32 hundredths and divide it among 9 hours of working time, that in each hour the guy will be able to do 3, and the total he'll be able to do over 9 hours is 27 hundredths. I still have 5 left to go. Got to bring down that 0. It's a place value holder. So now I'm looking at 50 tens or 500. 50 tens is 500, and I want to know how many of the 500 he can do in an hour, and he's got 9 hours to work. So let's see, 9 times what gives me something close to 50? 9 times 5 would be 45. 9 times 6 would be 54. I don't have 54, so 9 times 5 is 45. 5 times 9 is 45. So if in each hour he can do 50, in 9 hours he'll be able to do 45 tens or 450. Place value is important. Now he will have used up the next 450 of the patches. He'll still have 5 tens. And I'll bring down my 4 units. You'll still have 54 patches to do. Well, so now he's got 54 patches and 9 hours to work. So I want to know how many of those 54 he can do in each hour. So 9 times 5 is 45. 9 times 6 is 54. Perfect. So in each hour, he'll be able to do 6. 6 times 9 is 54. 54, he will have used up all of the patches in that time. And he'll be able to do 356 patches in each of 9 hours. In each hour of 9 hours. And during that 9-hour work time, he will have sewed together 3,204 patches. And that's our long division, the divisor, distributed among the 9 hours that this man has to work. Long division, pretty complicated. Think hard about it, see if you can figure it out. This is Mr. T, out to you snakes.